I'm going to demonstrate this Tektronix 7A19 scope plugin. This particular one, it's a Beaverton manufactured one, B041071. I hope you can see the serial number there if the camera focuses on that. It has mostly intact calibration labels, interestingly. I've never had to fiddle with it, but it's surplus to my requirements now, so I'm going to be selling it. I'm just going to demonstrate that it works okay by plugging it into my 7904A mainframe here. The mainframe is not included, the sale is just for the plug-in, so don't get your hopes up. So I'll switch on now and we'll start just with the basic test with the scope's internal calibrator. If I plug that in, there we go, we've got some tracer, a bit bright. Let's turn that down so we can see it properly. So we've got a 400 millivolt signal from the calibrator. If I adjust that, you can see that the vertical calibration is spot on there. This is showing 20 millivolts per centimeter. The calibrator has a 10:1 attenuator on, so it's 40 millivolts from the calibrator. We're showing exactly 2 divisions on the screen. I can crank it up 10 millivolts per centimeter. Oop, lost the triggering. And then we've got 4 divisions, and we can go through all the sensitivity settings one by one, and they all do what they're supposed to do. Attenuator works fine, nothing's burned out. Sometimes these are prone to having people operate radio transmitters into them and things, which damages the attenuator, but this is all, it's all good. If I just move this up a bit, you should be able to see that the trace invert feature works okay if I do that. DC balance is alright, no problem there. Identify feature works, and input coupling, we can put it on precharge, which is an attenuator. AC coupling works, it's got quite a high time constant on there, hence the distortion on the waveform. That's normal and good, because this plugin has a 50 ohm input impedance, because it's a very fast one. So that's basic functionality, it's working fine. What I'm going to do now is demonstrate it with a fast pulse input so you can see the bandwidth of the plug-in. If I unplug the calibrator, and I think 20 millivolts per centimeter should do the job here. Put that in. Ooh, a bit too sensitive. There we go. So this is a signal from a very fast pulse generator with a rise time of a few picoseconds, and I'm now speeding up the time base as fast as this scope will go. Hopefully you can see that alright. This is now running at 500 picoseconds per centimeter, which is pretty quick by analog scope standards. And this is the leading edge of a very fast rise time pulse from a Tektronix SD24 time domain reflectometer, and you can see the rise time here. The 10% point is about there, 90% point is there. I make that 700 picoseconds, which with the usual formula of 350 divided by the rise time in nanoseconds gives a bandwidth of 500 megahertz, which is exactly as it should be in this mainframe. So this plugin is definitely working up to scratch. It's not formally calibrated, but it seems to make accurate measurements. Seals haven't been broken and everything works as it should, including the bandwidth. Thanks for watching.